Hello and welcome back to another coding session with Mr. Jacob. Today we want to provide a patch to the open source plugin for Tauri, which is called the tauri-positioner. And the tauri-positioner actually allows us to position windows on the screen at certain positions, at certain predefined positions, something like put it in the top left corner or put it in the top right corner or something like that. A neat effect or a neat possibility of this positioner plugin is that it can actually handle tray icons, or in our case of the Mac here, window or menu bar icons, menu bar extras they are actually called on Mac OS as well. So you can do something that we did with our RetroPulse player, which we created in sessions before. I will link them above and below in the description, where we created this Tauri dev, this simple mod player, which is actually running and giving us a menu bar application that we can open up, as I'm doing here now, as you can see, and this one can then actually open up mod files and play them for us in the background. That's what we created there in the linked sessions. So if you're interested in that, take a look at that. However, today should not be really about the RetroPulse player, but about changing something within this positioner plugin. Because even though it is capable of positioning, and I know you can't see my menu bar currently because it's out of the capture window, so you have to believe me that the icon is kind of above the middle of this one here. It positions the window when we open it always at the center position below our icon, which is really neat, because we need a way to detect where this icon is and then open up the window at the corresponding position. That's actually something that's handled by this plugin. However, if we move this icon to one side of our monitor, like here, where the center position would cause it to be outside of the monitor region, as you can see here on the right side, then this thing will not position correctly, or it will position correctly. It will center the window below the icon. However, it will not take into account the monitor position to kind of constrain it by that. And I would really much like to have this feature, because this is not a good way to actually position this thing. I would like it to then simply move it a little bit to the left in this case here, so that it is fully displayed and not cut off on the right side. And that is actually what we are, or what we will be going to implement today, or try to implement in this plugin. So let's take a look at this plugin. I have already checked out the repository where this actually is stored in. It's in the Tauri organization under plugins workspace. They have a mono repo there, which has a plugins folder with all the different plugins they actually maintain. And there is this positioner thingy here, and that is actually our positioner plugin. So what I have did so far is I have already checked this one out here. So let's quickly go into this one and take a look. There are all the files in it, and then we should be able to actually work with that. However, how we are actually going to work with that, because I want to use our player here as a kind of a test bed, because it has all the code already in it to create the corresponding window, to position it in the center, and all of that stuff. So that we don't need to write it again as a simple testing example. However, what I need to do then is, I'm currently source story cargo toml. Let me quickly open that up. We are currently there we go. We are currently loading this, of course, as a version from Crates.io. So how would we actually do that? There is actually the possibility to define a patch. So to patch external resources, which are kind of defined here somewhere, to be loaded from Crates.io, to be able to kind of move their path, their lookup path to something, for example, on your file system, or something that you have in a Git repository or something like that, in order to do just what we want to do here. So what I can actually do here is I can the system that I want a new section called patch crates.io, and then I simply put in Tauri plugin positioner, and I tell it that I want to give it a different path. And this path actually should be something like // what was it called? I already forgot the name again. Plugins Workspace. That's actually where I checked it out. Plugins Workspace, plugins Positioner? Positioner. There we are. So plugins Workspace, plugins Positioner. And if we did everything right here, if I now build this again, so npm run tauri dev, let's see, it should actually build and take our local copy, and as you can see, it actually did that. It said compiling tauri plugin positioner from, wait a second, there the terminal scrolled away, unfortunately, from my actually here development folder where I have put this thing. Okay, so perfect. So now we can actually try and implement something on that. So let's take a look how this is actually structured. And I have only opened that up actually in the editor since the last time that we took a look at it in order to see how we actually need to use it. That was the one time we looked into the source code. So how does this actually work? There are actually two parts of this thing. There is this move window command there, which we from our part call in Rust. So we are actually using some sort of trait that is implemented here, if I remember correctly. Where was it? I guess they are implementing a trait on window, if I remember correctly. Not sure where this is actually done. Maybe here in extension. This is actually the positioning code. Yeah, they are actually on the window implementing this move window command, and you can give it this position struct, which actually defines something like what we are currently using, I think, tray bottom center or tray center, something like that. And then it will do all the positioning mod magic and position our window correctly. However, what I found, what I think is quite interesting is how it's actually doing that. It is doing that by being called on every tray event. So if we want to use that, we need to provide it with all the events that are happening on our tray icon or menu bar icon. It's actually the same thing. If you are on Linux or Windows, it's called a tray icon. If you're on Mac OS, it's called a menu bar icon. It's essentially the same thing. So in this code, it's called tray icon. And what they are doing here, they are actually on any event that is, on any mouse event that is fired on there, they are actually taking the position of this event to update the position where they need to position the window relative to. So that's the way they are actually extracting the position of the tray icon. And I guess what we need to do is we may need to do something more in here, or maybe in the positioning code itself, because what we need to do is we want a way to now kind of restrict this or constrain this to the monitor dimensions, so the screen dimensions. So we somehow need to get those. And I guess what we need to do is we need to somehow get the screen positions for this position that is detected here, or the screen, better said, the screen that this belongs to, because there may be more than one screen. That is something that I have in my setup here, for example. I have multiple screens, so the icon can actually appear on different screens. We need to detect that screen, and then we need to constrain the position to this screen. And I hope that this will be reasonably easy, maybe, by checking out this code. So what we currently have is we have something like move window, and we could now go ahead and maybe add something like yes, something like that's actually interesting. I could do something like on the tray commands here, I could do something like maybe introduce something more like tray bottom center constraint to indicate that we want it to be constrained. We could actually change the signature of this move window function to maybe have something like a constraint variable here of some sort, an argument of some sort that we want to introduce. However, that would break the API, and I would rather not do that. So what I'm thinking is there is on the window, actually, there is something like lib. Wait, let me quickly see how this was called. So Tauri, let's quickly open up the Tauri documentation. And let's see the window object event dialog. Was it called web view? I'm not sure. There is web view. Let's see. Is this the JavaScript? That's the JavaScript version of it. Isn't it? Yeah. That's not what I was looking for. Maybe we need to see in here window. Okay, there is a Tauri window, and this window, yes, a window managed by. And there was something, I think, set size constraints. So this is actually the size constraints that we can define on a window in order for it to kind of define what's its maximum size that it's or its minimum size, I guess. What is that? Sets the window's minimum inner width. Okay, so we can actually say that it mustn't be smaller than something if it's resizable. So the wording constraint is already in there. So what I'm thinking about is simply creating a new method here. Where are we? Extension. A new method here, which we simply call move window constraint, and then taking the same position arguments. And that's something that I would actually like to do. I guess that would be more or less an easy thing to do, I hope, because we can more or less reuse all of that code and then simply refactor that, more or less out to return the calculated physical position so that we can reuse all of the positioning code. We don't need to recreate it or something like that, and then simply take this given rectangle, constrain it to the coordinate space of the current screen, and we are done. That's actually something that I would like to do first. I would like to define a new function called something like move window, which takes a self, of course. Or it's not called move window, it's move window constraint, and it's taking a self, and it's taking a position, which is a position, of course, and it's returning a result, same as our move window function. And then we can actually kind of implement that the same way here on our web view window. So window constraint, we are doing more or less the same thing. This has to go move window constraint. There we go. And now we need to implement this, of course, here as well. So let's quickly do that. We can reorder those things in a second. So it tells a self and it takes a position, and it's called position, and of type position, that is called position, and it returns a result here. And at the moment, it simply does nothing. That should actually be okay. So now we shouldn't have any problems. What's that? Move window constraint. Pos, we can't. Yeah, because we called it position, didn't we? So yeah. So now this should kind of compile, hopefully. Let's maybe reformat the code quickly to make sure we have this. So this should still compile, but not do anything yet. So let's see if we can still compile our application here with this library. Okay, seems to still work. Perfect. So let's see how we are now refactoring that. So now what we want to do is we kind of want to create a new function called, or exactly kind of override this one and rename this one and call this one something like calculate position rectangle. Or calculate. What are we actually returning here? We are returning some sort of physical position, aren't we? So calculate physical position, then we could say it. Calculate physical position, we call it. And this one actually takes all of this and it returns a result now, which contains a physical position of what's the type that we are actually putting in there, an I32. So we are giving back the physical position as an I32. Okay, so that's actually something that we kind of want here. So let's see, we are doing all of that calculation stuff. We don't even really care about that. And then in the end, we are not doing set position, which would move the window actually, but we are simply returning the calculated position here. Okay. And yeah, that would be nice. And now this function needs to be at a different position because it is not part of our trait, which is perfectly fine, but we want it on our window. Do we actually need it to be on our window? That's the question. Yeah, we can decide that later on. Maybe we want it on our window, maybe we don't. Let's quickly see. Let's implement that for a runtime R, which we are generic over, and simply say we are implementing this for window R. And now we should be able to... I don't think we want that implemented on the window. If I'm thinking about that. Let's fix the code here quickly. So this should be an empty result now as well. I don't think we want it there. I'm not even sure we can do that. No, we can't do that. We could implement that for, yeah. So what I guess we want is we want simply a function that does that for us, which would be all right, I think. However, then we need to provide a reference to the window here, which is generic over the runtime. And this one would be called window. So now we should actually be able to replace all of those selves here. Let's see. What did I do? That's not what I wanted to do. Calculate. There we are. So let's simply use the multi-cursors thingy here. No, I didn't want to run and debug. Ah, come on. Even though I wanted to use this more, let's not use this. Let's simply mark all of this stuff and then throw a regular expression against it to replace self with, what did I just call it? Window. And there we are. So now this should actually work. The problem here is expected type, font local variable. Yes, that's perfectly reasonable. I want a reference to this type there. And now this should more or less still compile. So let's see. Now we need an implementation for move window. So what we are actually doing here is we are doing let, let's call this one position. Let position equal calculate position and so on, and this window will be self, and we are putting the position in there and actually doing that, and then we will return an OK here, and we will do self set, no, not set always on bottom, but set position, and we will just put the position in there. And does this actually return a result? This actually returns a result, so that's actually kind of perfect here, so we can reuse that. And now we should actually still have the same functionality as we had before. Let's quickly test that so that we did not break anything. Okay, could not compile. What did I do wrong? Position expected physical position I32 found position. Okay. Wait, what? I think I may have returned the wrong thing here. Wait a second. What did I do there? I told it that I would return a physical position. I'm not sure that physical position is actually what I'm returning here. I'm returning a tauri-position physical, which is something different, I guess. So yeah. So let's change that. So this is a tauri-position physical. Expected type found variant. Okay, so okay, I see. So the enumeration actually is position, and there are okay. So I guess that this is completely irrelevant in this situation, and we can simply say that we can call this calculate position actually then. It's simply providing us with the position of the window that we want. It essentially is a physical position, but we don't really care about that, do we? Because the window positioning function here simply takes a position. Okay, yeah, that kind of makes sense. So let's see if this now compiles. It's building. Gone. Okay, so it's running, and if I click here, it's still positioning relative to the icon. That's okay, so that's still working. That's already quite nice. So now we should actually be able to finally implement our move window constraint function. So what we are doing there then is we are taking the position, and let's for now still return okay here. We are taking the position, so by I think I want to kind of rename this position. Wait, what? Calculate. Didn't I rename this just a second ago? Strange. Okay. So now we have this calculate position there, and we now have our position, and now we need to constrain it to the actual monitor that we are displaying on. So how they are actually calculating the position based on the current monitor. However, is that correct, or would that explain another bug behavior or another behavior that I experience? The problem that I'm thinking about here, they are kind of calculating relative to where are they using the screen position here actually? They are actually using the screen position to position X and Y relative to the okay. But that only makes sense in case of the position request which is not based on the tray icon. Do they use that for the tray positioning as well? Because that would be actually wrong, I think. So I think they are not. So this is perfectly fine. The reason I'm thinking about this here is that the current monitor is not or must not be it's not guaranteed to be the one that we clicked the icon on, that the icon actually is on. It might be that I click that on the not active monitor, and then the calculation would be off if we used that here. So I can't actually do the same thing when they are using here, simply getting the current monitor. Maybe we should put something like, or yeah, I could put a comment over here saying that only use the screen position for the tray independent. Is that actually how you write independent? I have no idea. A tray independent positioning, because a tray event may not be called on the currently active monitor. Yeah, we will see if we leave that in later on. It's now just for me to make sure I'm thinking right here. So what we actually need to do is we need to kind of, when doing this move window constraint, calculate or find the correct screen. So what we can do actually, or should be able to do here, is we should be able to do something like self. Isn't there something like current monitors monitor from point? Wait. That's actually something that is there. Returns the monitor that contains the given point. That's actually exactly what we need. Okay, so that's actually quite neat here. So what we need to do now is we need to take this position and we need to wait, we may need the tray position as well, don't we? So let tray position, tray size, window state. Yeah. They are actually extracting the tray thingy, the tray icon information here. That's what we need actually here as well. So let's maybe introduce a new function here, something like get monitor for or by get monitor for tray icon, something like that. And we put in there a window reference, again, and then this needs to be generic over the runtime, and it will return a result containing a monitor, or what was this? Let's see what this returns. So let monitor, or let's quickly put in this here, and this should be there. We only want this function if the tray icon feature is enabled, and we get all of that info. I'm not even 100% sure that I need it this way, but yeah, why not? So so now we should have the tray position and the tray size. So we should be able to do something, if this actually works out, to tell it that we want from the window, what was it? Monitor from point, and then tray position.x, tray position.y, and I guess the inputs will not be okay here. So this action actually returns an option monitor. So there might be that we are not getting a monitor back. Yeah, that actually kind of makes sense. So option monitor, let's return the same thing here. Let's import the tauri monitor here. Wait, what? That's definitely not what the editor should have done actually. So we want tauri. We want tauri, use tauri monitor if the tray icon feature come on is active, something like that. Okay. And now what we want to do is we need to take into account that this is not expected to be an i32, but it should be an F64. So that's actually interesting. So wait a second. Why is this an option? Because we are putting it in an option, that kind of makes no sense. So let's maybe change this a little. So what we don't need the size here. We only need the position. So let's change the code in the way that we actually need it to. So that is something that we have in our state, and we have this in our state actually as we have this as a physical position f64. So that actually kind of makes things a little bit easier for us. We don't need the size, and what we actually want here is we want can we do something like pos to, can we convert that into something maybe? Okay, let's just do something like pos x, comma pos y, and this should actually extract our position as an f64 pair. What's the problem here now? No field. Yeah, that's because we need to do now this. However, I'm not even sure that I want to do it like that. I think I want to do it like that. I think I just want the physical position, and then I can simply do it like that. Yeah, okay. And this should maybe give us the monitor for our tray icon, if it can actually find that one. We will see that in a second. So now what we should be able to do is we should be able to call that from here. So we should be able to do something like let monitor equal get monitor from tray icon and input self in here, and this can fail, I guess. So let's shortcut there, and this might be not, you might not be able to do that. So we do something like if let sum monitor equals monitor. Then we want to do some constraint positioning, else fall back on non-constraint positioning. So if we can't get the monitor, we simply fall back to self move window. I guess like that. It doesn't like that. It doesn't like that because oh, yes. So we can simply fall back on setting the position directly, I guess. So okay, so however, if we have a monitor, then we want to do some clamping there. So can we actually get from the monitor the we can get the position, we can get the size, which is the physical size as a U32. That kind of is a good thing. So let monitor size equal monitor size. And I guess let's quickly see. We only want to actually constrain those positions if we are in the tray icon mode. So maybe we only provide this whole move window constraint function only if we actually have that feature enabled. That kind of makes sense as well. I was just thinking about checking which position was put in here to then do the position calculation. We may need that anyways. However, I guess we can do something like that and simply tell the system that we only want this in case this feature is enabled. Otherwise, this method doesn't even exist. That kind of makes sense, I guess. Okay. So, yeah. And what we are doing now is we are simply doing we are doing a quick check and seeing or maybe we can do that later to do diverge here into normal positioning if no tray position is used, and we do that later on. Let's get this to work at all now. Okay, so now we have something like monitor size. We get the monitor size there. After we have the monitor size as a physical size U32, we should be able to actually constrain our position of the window. We, however, need the let window size, I guess. We need that as well. So that would be a self. Can we actually get that inner position? Is there something like we need outer? Is there something like outer size or something like that? Dimensions, maybe? Okay. I need to take a look into the documentation and see. We have still open the struct window here. There must be something with size. Start resizing, hash size. Okay, that's all. Set max size. I want something like, is it maybe get size or something like that? Get. Set min size, set position, resizable, set size. I would have assumed there must be a way to get the current size of the outer size. Returns the physical size of the entire window. These dimensions include the title bar and borders. If you don't want that, and you usually don't, use inner size instead. Yeah, but we want, because we need to position the window based on that. So we want the outer size. Okay, so let's quickly get that. So window size would be self outer size. There we are. And this is now, yeah, the outer size of the window. So what we want now is we have the top left position of this thing and we have its outer size. So we can kind of calculate that it is definitely within our monitor region. So what we want now is we want to create a new position, I guess. So we want tauri position physical, because we are in the physical realm, and this one holds what exactly? It holds, okay, a physical position. So this is simply this is simply the variant that we are using there. So we might want to change this one again a little. So this one really should return a physical position of I32. And we can then later on stuff that into the variant. Let me see. Okay. Just to make things a little bit neater here. Okay, so mismatched expected physical position found. Wait, what? Oh. How did I remove the result around that? Okay, so now this should actually work out. It does. And now we should do, where are we using that thing? Because there we need to, actually put that into, this is taking, oh, interesting. So this is actually perfectly fine. We can actually do that because the methods that we are using it with are taking, or are actually generic over the position, and it only needs to be convertible into a position. And I guess a physical position is convertible into a tauri position. Okay, that's actually quite nice. So what we need now is something like, we want our window constraint implementation. So we have our physical position here, and we have our window size. So what we now need to create is we need to let constraint position be a physical position, physical position. And how are we actually creating that one? Does it have a new function? It has a new function. Okay, nice. So that it will choose the type correctly, I guess. So it takes the X and the Y. So what we now want is we need to make sure that the X and the Y is within its limits. So maybe what we want to do is we want to calculate that separately first. So constraint. Let's do the x first. So the constraint x will actually be something that depends on if the wait a second, the position x plus the window size dot x will be greater than the monitor size dot x. However, we need the monitor starting point somewhere as well. So is there something like monitor position equals monitor position? Yes. Because you might think that the monitor position is always at the 0, 0 position. However, if you have multiple screens, one of that could be to the left or to the bottom of another, and they are relative to each other. So we might even have a negative value here if it's, for example, left to your primary screen or something like that. So what we need to do is we need to do something like we take the monitor size and the monitor position.x, and if we add this together, and if the right position of our window is bigger than the monitor position, then we want to move the window to the left. Can we actually, because we want to move it to the other side as well, if it's the other direction, can we calculate this a little bit more intelligently by simply somehow calculating this offset that we need there? So let's think about that. So we would have something, and I guess I will remove all of that in a second, but I want to think about how to calculate that. We would have something like the right border monitor, kind of. So this would be monitor position x plus monitor size x. So that is something that we have. And we can't do that because those values are a U32 and an I32. Yeah, that makes sense. The question is, that could actually go out of bounds. So, does this only needs a position? It doesn't tell us what kind of position. So I guess what we could do is something like we can convert both of those into an I64 here, maybe, just to not lose any information there. So yeah, and it's not X, of course, it's the width. Okay, so then we have left border monitor. Come on, monitor equals monitor position dot y as I64 plus monitor size dot width. Wait, no. The left border would only be the y position. Yes. Okay. And then we would have in the end the same thing for the top and the bottom. So the question is now, how can we use this information and the information about the right border window equal window size dot x as I64 plus not window size, but position, sorry, and window size dot width as I64, and essentially the is it not called window position? It's called, let's call this window position here, window position. And this is window size. However, window size, I don't have something like window size. Wait, there we have something. That's a physical size. Oh, it's a result. So I need simply a question mark here. Okay, and we now have this window position, window size, something, something. So we need this for the left border as well. So left border window is simply the y. No, that doesn't make sense. What did I do there? It's simply the x. Um. Okay. Okay. So we have that. Um. We have that. So we have the right border. We have the left border, we have the right border of the window, and we have the left border of the window. And now we somehow need to make sure that we take the one that is bigger for the left one and smaller for the right one. So I'm just thinking that we can do this with min and max, of course. However, I'm thinking if we could kind of simply clamp those values to each other. No, we can't, I guess, because we need to calculate the position of the window. So yeah, so we have our position. That's the left border is always our base position here. So I guess we need to calculate that based on the movement anyways. Because we need to move the position of our window if it would be outside to the left or outside to the right. So let's see. So if right border monitor, or no, if let's start with the left one. Left border. If the left border of the window is smaller than the left border of the monitor, then our position will be the monitor border, so that we really simply align it on the left to the left monitor border. So in this case, this will be left border monitor. Let's constraint x equals this one. Else if right border monitor, right border window is bigger than right border monitor, then take then we take the right border monitor minus window size dot width as I64, I guess. Yeah. Because then we want to position it from the right border, the size of the window. Yeah, and I guess if it's not in this position at all, then we simply use the original position X as an I64. And this would be window position X. Yeah. So if it's not left or right of the screen, then we can simply position it the way it was. Okay, that was really kind of fucking up my brain, even though it is a quite simple calculation, actually. So let's do quickly the same thing again for the top and bottom. So we have the bottom border monitor would be the Y position of the monitor plus the monitor height. We have the top border of the monitor, which is the monitor positions Y. We have the right border of the window, which is now the bottom border of the window, which is the window position Y plus the height of the window. So it's essentially more or less the same thing. We have the top border of the window, which simply is the Y position of the window. And now we have a constraint. Wait, what? What did I do there? Let me copy that. We have a constraint Y, so that we want it to be if top border window. Come on. We're simply replacing all lefts with top, and we are replacing all rights with bottom. And then we should more or less have things right, except that we need to get the window size height off here, and this would be the Y position. And now we should actually be able to simply use this constraint position to position our windows. So self set position, and we are creating a new physical position from constraint. Or constraint, that's actually, I've written that wrong. Constraint, or did I? I have no idea. X and Y, and doing it like that, hopefully. And this does not work because the trait bound I64 pixel is not satisfied. The following other types implement trait pixel. Okay, so we needed some sort of different thingy here. So yeah, so let's simply move this to the floating point realm, even though those aren't floating points. However, yeah, we are not 100% sure that we can store that then, but we should be able to store that because it would be kind of strange, I guess. So I64, let's replace that with F64, and we should be good to go. Okay. Okay. So now we have move window constraint and kind of implemented that. So let's maybe first of all take a look if this even still compiles. Okay, I guess it compiles because it is still running here. So now let's go into our RetroPulse source code. Actually source, and let's see where we are doing that. I guess in tray, and there we should have something like move window, tauri-positioner, tray bottom, and so on. And we simply change that to move window constraint. And then we recompile and start that again. And if we did that right, then now the window should be positioned correctly based on the border of the screen. So let's see if this actually is working. Wait, what? Waiting for file log on build directory? Oh, that could be, yeah, I guess my Visual Studio Code built that in the background as well. So let's see. Let's see. Come on, build it a little bit quicker, please. We didn't change that much, did we? Yeah, so I guess there's our icon now. Let's see. Okay, so this is the usual normal positioning. Let me move that around a little and a little more here. Oops, that was the wrong one. Yeah, this works. And now let's go to the edge of the screen, and this. Interesting. So it is working now. It has positioned it. However, it did not do so the first time it showed up. So that's kind of interesting. So let's move that again there. And this is still not, it may not be able to get this position then. That's when I'm in the process of kind of moving the icon. That might be something that we need to look into. That might be the path where we weren't able to determine the monitor that we are on. So that it then does normal positioning, because as we moved it, we might not have proper coordinates for that thing. However, we seem to have coordinates for that thing because it is displayed at this position. That's interesting. We may need to debug that a little bit. However, that's the moving part. And when I then click it again, it is now positioned correctly. It's not centered under the icon anymore. However, it is now positioned, as you can see here, with the correct constraints. So that actually works like it should. That's actually a nice thing. So we achieved what we wanted to achieve. And actually, it wasn't that complicated, even though my brain kind of collapsed when doing this calculation. And I'm still not sure that there isn't a much neater way to actually do this kind of calculation. It's kind of, I'm not 100% sure that this is the neatest way to do that. And of course, we need to kind of implement the shortcut here still to, if the position is one of those, then we actually want to kind of diverge into the normal, not constrained moving. However, I guess we have that now. And yeah, I guess I will clean it up a little bit off screen, and then I will propose a pull request to the Tauri plugin, and with a little bit of hope, someone will review it, and we will have that in the tauri-positioner plugin in the next version. So yeah, I hope you had fun joining me, refactoring and implementing this stuff in this plugin here, and doing a little bit of open source work, so to speak. And yeah, propose some changes to the tauri-positioner plugin there that might come in handy in the future. I hope you had fun. I hope you will join me in the next one. If you had fun and want to be informed of the next videos, please, for one, hit the like button. The second thing is, please hit the subscribe button and hit the bell to be informed when the next ones are coming out. And I hope to see you in the next one, when we will be doing something funny again with the shell and maybe a little bit of animated GIF there. So yeah, I hope to see you in the next one. Bye.